So, you've probably seen this formula before. It's Euler's formula that relates exponential functions, the, the trig functions, and you have I here. And E, so you got a lot of mathematical constants. And how did we get to this? Well, I'm here to derive it in my own interpretation. So what we do is, well, what I would do is first draw up a complex plane. Complex plane. There's the imaginary axis and real axis. Okay, so next, we've seen trig functions. The head goes to unit circle because unit circle is all about trigonometry. We have an angle theta and we get a point. Let's say this is our radius r. Okay, so we know from trig that this height is sine theta. This length here is cosine theta. This point here is cosine theta by sine theta because this is the imaginary axis here. So it's multiple everything. The distance from the origin is just multiplied by I. Okay. Next, we can look at a Cartesian form of a complex number. It's an a plus bi, and we've already a is just cosine theta, and then b is sine theta. But let's just put the I out in front because it matches. Okay, so we've got that the right hand side, but how do we get to the left hand side? This is why I want to employ some calculus because I have e and exponential functions, natural base of language of calculus. So now let's differentiate. Let's differentiate e to the I theta. Oh, not with respect to x, with respect to theta. Well, you could use x, you could use that. It just changes your variable. It really means the same thing. And this is I e to I theta. Okay, that's cool. Just chain rule. But let's just differentiate the right hand side here. And this is equal to derivative of cosine is negative sine. Derivative of I sine, well, I is a constant, even though it's imaginary, it's still a constant, it's not a function, which is sine theta. The derivative is cosine theta. So just add I cosine theta. This looks really similar. Just remember the fact that I squared is equal to negative 1. Hence, I feel like this is all we just multiplied an I on that. And cosine, just add an I. This multiplied by I times I is negative 1. So, think about it. Well, we have I times some derivative, let's just call it y prime. No, sorry. A derivative is equal to I times some function y, which is cosine theta plus I sine theta. And hang on, that's this here. Because we just use the chain rule to bring this out. Oh, well that means they should be equal. Because you're right. that's it. So we can really say theta is equal to cosine theta plus I sine theta. And that's the reasoning. That's my interpretation. Let me know if you got another method on deriving the formula, but I feel it's a good time to do the box. And thank you.